program or not to program? That is the question. Welcome back to ABAGY Robotic Welding. And today we're going to arrange a welding race. 1, programmed with ABAGY, and 2, the old-fashioned way with the Teach-pendant. So, welcome back, and subscribe to us, and put in some comments if you want to engage with our experts. So let's go. Welcome to the welding programming race. In the pink corner, ABAGY. In the other pink corner, traditional. So, run me through what's going to happen here. These are the test pieces.
Yep, we prepared 2 nearly identical workpieces, and they have plenty of different seams, but we will work with only few of them.
Okay.
First of them will be this one.
This one here, yeah.
Yeah.
Ooh.
It seems to be quite easy and short, but it has some trickiness.
It's very curvy.
Yes, exactly.
Yeah, great.
So that's why it's hard for programming it with the old-fashioned way. You will see.
Yeah.
But with ABAGY, I believe it will be just very fast and easy. Okay. The second seam is this round one. With this round one, what we will need to do for it to be flawless is to rotate the positioner and the robot simultaneously at the same time.
Yeah.
And with the manual programming, it will be hard to do. So I believe that this will be also our advantage.
Okay. The third one?
The third one will be this long path inside. So tell me what can be problematic with this.
Well, it's very tight. To get the nozzle in there, yeah, that's
yes.
You don't have much freedom to maneuver, but we'll see.
Yes.
And this will all be against the clock. So you'll be using the panel over there, and you will be using the Teach-pendant. Ready to go?
Yeah.
And we did something similar last time.
Yep.
That video is also online, showing how you put the thing on the positioner and then you get onto the panel and make it work. It's tight. Oh, very old school.
Before I start programming, I first need to redraw the part. Any trajectory is at least 2 points. If we are talking about circular arc, it means at least 3 points. But we have a round seam. I think 4 points are enough. I number them so I don't get confused later when I will program, and then check the trajectories during a dry run.
And this is the way welding programming has been done for decades? Many years?
Yes, this programming method was created by robot manufacturers themselves, but it is still the most common. So let's start programming. I take a Teach-pendant for this. I define the first point. I need to describe it through code. In this case, I use FANUC programming language. Each robot manufacturer has its language. Now we will program each robot trajectory point by point, every single robot movement.
I'll let you work in peace. I'll go over here and see what's going on. Good luck. Okay. So, we have motion.
Yep, like in the ABAGY way, the welds.
Yeah.
And now I have the vision data to confirm.
Ah, yeah.
And you see
That's like what we saw last time. Yeah, this
Yeah.
dot picture.
Yeah.
And you've this loaded today on your laptop. So you can use the interface there or your laptop.
Yes, exactly.
Yeah? Okay, great.
Okay, so I believe that the position we have here is pretty close to what I can see by my eyes. Okay, that is why I may set confirm. And now it will start like touch sensing and welding already.
It'll start welding already.
No, it is currently planning the way it will like move with its links. So now I may just sit back, relax, try to think about future of robotic welding and so
Right.
while it's working and while Ego is working, okay? So my grandpa, he was not used to washing machines,
Okay.
okay? And when we bought him a washing machine,
Yeah.
he standed there and just looked at it while it washed.
It's the magic of technology. Yeah.
Because he was really thinking that it's necessary to wash while it's working. Yeah. For us, it's not necessary to wash, but it's like
But it
fun.
looks cool.
It's cool, so I'll do it. And you see, the positioner rotates, and while it rotates, the angle of the weld remains the same.
Yeah.
It's PA welding. So you see, actually, for these corner points, it's not that easy for the torch to reach the point. So it's good that I was not forced to program it by hand, as our software did this program.
Yeah, it's still ongoing over there.
So before each weld, it just makes the cut for the wire to be like precisely of expected length.
Great.
So actually both robot joints and the positioner currently moves. You may not see the like the moves from the robot links, but they are because the cylinder is not centered exactly at the center of the positioner.
Well, I guess I'll see it online later.
Yeah. Great. We're done.
We are robots. Done?
Yeah.
Stop the clock.
So let's start from this path inside. Okay. I believe that it's pretty close to what we expected. The end of the next seam starting like it's in the starting position of the previous one,
Right.
and that is why the metal amount in general is quite the same.
Yeah, it looks very smooth.
Yeah, and the round seam is quite like nice.
Yeah, it looks
like
really nice, yeah.
Really nice.
How goes it?
The process is underway. Now I need to rotate the positioner and then move the robot to the next point. I see that I need to change the angle, and I am doing it with the Teach-pendant, and I'm using markup I made at the beginning.
So each axis you're manipulating by a touch of those buttons.
Yeah, this is correct. And I continue to program point by point.
Cool. So we're here, we're enjoying some downtime. Your colleague is there continually programming. It's very impressive, the piece is finished. You went to the computer, you did some stuff, and you made it magically just do its job. Could you just pull the lid off that and explain how it works?
Let me try, okay? Let me try. So, the very important thing of this is that we have this computer vision. So without this computer vision, it would be hard. Because like, you need a man with his eyes, right? Mm-hmm. What we need to achieve is that we don't need the man without man. So with the computer vision, we have these point clouds, so-called. It may not tell you that, for example, it's a chair, but it may tell you that's the borders of the shell. Like it's like it assumes that it's some shell, and the points are actually on the border of the shell. Mm-hmm. And then we compare it with a 3D model we have to understand where the actual workpiece is located. And for that, we need some algorithm for the matching between cloud of points and the 3D model.
You said the A word. Brilliant. Algorithms. So
yeah.
How do algorithms and modern tech come into this?
So I believe that computer vision algorithms are already like widely used elsewhere, but in robotic welding, we are doing some new thing in order to mix things which are already somehow work in other areas. That is why when we mix these technologies together, we achieve what you saw today, that we may just pick something on screen and let the robot do all the rest.
Cool. So you've shown me the ultra modern way of doing it. Your colleague is back in the room doing the conventional way. What about old school welding with a man and a torch? Could we get a workpiece and somebody to demo that?
So you want to challenge us, I believe, right, today?
I want to, when people think welding, they often think of the person with the torch.
I agree.
So if we could go ultra old school.
Yeah.
Yeah. Is that something you'd be able to do here?
Yeah, we may try.
Yeah.
We may ask Mike, our engineer, to do the same welds.
Right.
And see what will be the quality.
Oh.
Because for the very good quality, you need high level professional. I believe Mike is just he may weld, but it's not his primary topic. Okay.
Okay, let's go find Mike.
Yeah. Mike.
Oh.
Please help us.
Hey.
Hey, this is Mike.
Nice to meet you.
Nice to meet you.
All right.
We want to ask you to weld some seams for us, okay? Today.
Okay.
This is the workpiece, I guess.
Yeah.
Yeah.
So I did this with the robots today, and we want to achieve it with manual welding.
Okay.
We have 3 seams here.
That's right. The first one is this curvy guy here. The next one is around the top. And the third and final one is all the way around on the inside into those corners.
Okay.
Yeah. You up for it?
Let's go.
Yeah.
Yep.
Cool.
So with this tool, it's not that profound the one on the robot. So the seam will not be very
cool, not so bright.
good. And also for some seams, Mike will need to have several passes for the right amount of metal to be there. Great. So it's quite difficult to preserve the trajectory by using your hand. Mike, just okay. So we see some artifacts here, okay, because of the complex rounding.
Yeah.
You see that the metal amount here is more.
Yeah,
that's the problem.
That's not an easy seam, especially around the bend.
Because you need to change your position, right, Mike?
Here.
So what we see here is that actually Mike did some first seam. It's quite, you see, small.
But it's good.
Yeah, it's small, but it is needed because you see we have a big gap between the parts of the detail, okay, of the workpiece. That is why we need to first fill it with some metal, and then after that, with the second pass, we will bring more metal on the top. Yeah, and you see, when you work with hand, you don't have the positioner which rotates.
That's right.
That is why you see these smaller seams actually. The bigger seam is cut into several smaller ones. So it's less.
It's craftsmanship. There's a lot of good skill
Yeah.
involved.
Okay, so
Cool, yeah,
the second pass, right? You see, he actually moves the wire back and forth, like left and right, in order for the seam to be like more thinner.
Yeah, yeah. Cool.
Are you done? Yeah. Great. So let us check what we have here. Well, it's currently it's much more similar,
Yeah.
right?
Yeah, that's it.
Yeah.
Looking good.
Good. And we may see that for this seam, it took more time.
Yeah, I was
by
about
hand.
to say, yeah, it's a time-intensive.
Procedure, right?
Yeah.
Great. So we have this round one
Yeah.
below, and it's very similar with the top one, right?
It's good.
Yeah. And also with two passes.
Yeah, yeah.
So the round movement of hand is reflected in how the metal is bended. Yeah.
Well, all I can say is it's a job well done.
Yeah. Thank you, Mike.
Yeah, thank you guys.
Cheers, Mike.
See you later.
Yeah. Let's go check on your colleague.
Yeah.
Yeah. Okay. Ooh. Let's see how we're doing. Hello. How's progress?
It remains for me to check my trajectories. I need to check every step. I do this at a slow speed for safety.
In the interest of time and the amount of work you've put in, could we stop the clock and just, well, weld what we have so far so we can compare the seam? It's kind of obvious at this point what's the most efficient way to do it. But let's just weld the stuff, what we have so far, and see how they look compared to each other. Oh.
You see that it is being welded with a PB mold,
Yeah.
which is not like this angle, right?
Yeah.
It's like this.
Yeah. That's it?
Yeah.
Nice. Ta-da! Right, finished product. Okay. So we've got your work, we've got your work, and we've got Mike's work here too. First, let's go through the quality of the seams.
With the robot welding, I believe the seams are quite comparable. They're good in both situations. I like it. With manual welding, I see a lot of complexity of doing this by hand, and that is why they are not that smooth as we might expect with the robot. Mike was good. Yeah.
The other main factor is the duration, and it was clear that you were done very fast, and you had a lot of time needed. So yeah, we stopped the clock early. It was clear what was the most efficient. Thank you, guys. Well done. Thank you. Good job. Cheers. Woohoo. Thank you for staying with us till the end. We're going to bring you more stuff from the world of welding and our innovation here. So subscribe, and if you see anything you want to talk about further with the engineers, write it in the comments. Thanks.